Welcome back, kiddos. This is Solutions, page 133, numbers 33 to 37. Block sliding down an inclined plane. So, question 33 asks, let's see, where are we? Yes. Okay. An ant climbs at a steady speed up a hill, which is inclined at 30 degrees from the vertical. Inclined at 30 degrees from the vertical. Sketch a free body diagram for the ant. So, this is not drawn to scale because I didn't read the question clearly. 30 degrees from the vertical would mean this is a 30-degree angle, so this is not drawn to scale. But here is a free body diagram where we have the ant, and you could draw something more better like this, an ant, but here is our box ant. We have a force downward, that's the weight or the pull of gravity. The normal force is the block pushing up on the ant. Because the ant is moving up, there has to be some force in the upward direction, or else the ant would slide down, and that is the push of the legs. You could also say it's the friction of the block on the ant's feet, but however you want to describe it, there is a force in the upward direction. So there are a total of 3 forces acting on the ant. Question 34. Scott and Becca are moving a folding table out of the sunlight. A cup of lemonade with a mass of 40.44 kilograms is on the table. Scott lifts his end on the table before Becca does, and as a result, the table makes an angle of 15 degrees with the horizontal. So notice there's a difference between with the vertical and with the horizontal. Find the components of the cup's weight that are parallel and perpendicular to the plane. So, this is definitely block and inclined plane type situation. Here is our table. Here's our cup of lemonade, and 15 degrees with respect to the horizontal. So again, weight pulls straight down, and make this triangle where one side is parallel to the plane and the other is perpendicular. And you do that always, okay? If this angle is 15 degrees, this angle is going to be 15 degrees. So frequently we will write theta and theta, and use our SOHCAHTOA skills to figure out what this side is and what this side is. And you're probably catching on at this point where that side, the perpendicular side, will end up being mg times cosine theta, and the parallel side will have a value mg sine theta, as long as it is this angle theta that we're talking about. So, plugging in gave us something like mass g this, and notice how these values are in newtons. They are forces. So parallel, this would be 1.12 newtons, and the perpendicular component looks like 4.17 newtons. 4.17 newtons. And notice how both of those are actually less than the real weight. Okay, and they don't necessarily, actually, they're not going to add up to the weight because they're in different directions. Okay. 35. Kohana, who has a mass of 50 kilograms, is at the dentist's office having her teeth cleaned. Love the dentist, as shown in that figure. If the component of her weight perpendicular to the plane of the seat of the chair is 449 newtons, at what angle is the chair tilted? So that diagram was totally confusing because the chair is at all kinds of angles, so I redrew it. Here's Kohana, poor box person. Here's the dentist chair, and her weight is force straight down. It is broken down into perpendicular and parallel components, and The question tells us that the perpendicular component is 449 newtons. So, from previous question and previous question and previous questions, we knew that the perpendicular component, or F sub n, normal force, will be equal to mg cos theta. What was that? I said normal force mg cos theta, as long as the angle we're talking about, theta, is that angle listed. Okay, so plugged in. Did use my algebra skills here, dividing this by this, and then I'm taking the inverse cosine to find theta, making sure my calculator is in degree mode. Degree mode. What mood are you in, calculator? 23.6 degrees. Very nice. Moving on. Question 36 says something to the effect of Fernando, who has a mass of 43 kilograms, slides down the banister at his grandparents' house. I'm sure they loved that. If the banister makes an angle of 35 degrees with the horizontal, what is the normal force between Fernando and the banister? So, here's our block Fernando. Here's the grandpa's banister. Look at this. Normal force is mg cos theta. We're seeing that a lot. So, I just plugged in and got 345.2 newtons. Piece of cake. 37. A suitcase is on an inclined plane. Suitcase. Inclined plane. At what angle relative to the vertical, will the component of the suitcase's weight parallel to the plane be equal to half the perpendicular component? Woo! Parallel equals half perpendicular. So, again, parallel component, perpendicular component, and this question is saying that the parallel equals half the perpendicular. Parallel equals half the perpendicular. Notice how mg cancels out. I divided both sides by cosine theta to get 1/2 is sine theta over cosine theta. Use my basic trig skills to know that sine over cosine is tangent. And so to find theta, I can take the inverse tangent of 1/2, and calculator says 26.6 degrees. Now, look at what I have. Okay, this theta is with respect, this is this theta. Okay, so this is with the angle of the banister with respect to the horizontal. The question, I'm sorry, this is not a banister. That was the previous question. The way we have it set up, where this theta equals this theta, which it has to be set up if you want these to be true, this is with respect to the horizontal. So let's pay attention to what the question is asking. It is asking about the angle with respect to the vertical. So if this is 26, we know that this angle with respect to the vertical is going to be 90 minus that, giving us 63.4 degrees. All right.